Hello class, this is Mr. Martin here. I'm going to work a couple problems for you today. The first one I'm going to work is on page 87 of your textbook. And it is number 34. This is part of your homework tonight. Your homework tonight was problems number 29 through 38 and also number 60 and number 61. So this one falls in that category. This is part of the new ones. And it says find the empirical formulas. So find the empirical formula. Okay, so let's kind of get started here. So it says here that there is 1.67 grams of cerium, Ce, and also in the compound there's 4.54 grams of iodine. Okay, so we have these two elements and there's a certain mass of each one and they are supposed to make one compound. And so here's the steps, and I'm going to list the steps as we go. And the step number one is to change grams to moles. Change grams to moles. Alright, so here we go. Let's do cerium first. So for cerium, should be 1.67 grams of cerium. And I'm going to put that over 1. I'm going to change it to moles, and if you use the periodic table, you'll find that cerium has a mass of 140.1 grams per mole. Now, I want moles, so in my conversion factor, I'm going to put moles in the numerator, and I'm going to divide by the grams, which is 140.1 grams of cerium. So the grams will cancel out, and it gives me a mole of 0.012 moles cerium. Alright, so now let's do the same for iodine. So iodine, it says it has 4.54 grams iodine all over 1. And again, I look at the periodic table, it's going to be the same type of conversion factor, but because it is iodine, it has a mass of 126.9 grams iodine. So these units will cancel out, and I'm going to divide 4.54 by 126.9, and it gives me 0.036 moles of iodine. Alright, so then step number 2, and I'm going to need a new page, but I want you to make a note of this, 0.012 moles of cerium and 0.036 moles of iodine. So here's your question. Which is smaller? You must choose the smaller mole. And I can tell right now it's 0.012 moles of cerium is smaller than 0.036. So I'm going to divide cerium by 0.012 and I'm going to divide iodine by 0.012, and it will it'll give us a ratio. So let's see here. Let's choose a new page. So here's what we're going to do. Step number 2, divide by smallest mole. Okay, and we said it was cerium, and here's what it was. Cerium was 0.012 moles. Cerium. So I'm going to divide it by itself. 0.012 moles. And it gives me 1. Of course it does. So that means that cerium is going to have a little subscript 1. And then if we have iodine, we found that iodine was 0.036 moles of iodine. I'm going to divide it by the cerium moles because it is smaller. Okay, if you look at this, it's really 36 divided by 12. No matter what, see how everything is lined up? The decimal points are all lined up. So it's really 36 divided by 12, and it's just the same as it was if it were in any other position. So 36 divided by 12 happens to be 3. And that's my other whole number. And that's the last part. This is iodine subscript 3. Now I'm going to put them together for the empirical formula. And it's cerium, and I don't have to put the 1. It's like understood. But I'll put the I3. There it is. That's your answer to number 34, and that's how you do it. I hope this helps out. I will work another problem.